I'm going to apologize for giving this in English. I hope you can follow me. I'd like to thank the organizer for this terrific conference and for inviting me to present our project. I also wish to dedicate my contribution to the memory of Richard Cobb, who many of you will know. As, he had a very long and illustrious career as a senior archaeologist at the Smithsonian Tropical Research Institute in Panama. 20 years ago, he approached me about whether I would be interested in undertaking a technical study of the metalwork that he and colleagues had excavated at the mortuary site of Cerro Antillas. I was an archaeological objects conservator on the staff at the Museum Conservation Institute just outside of Washington, D.C., and I immediately said yes. And thus began the most wonderful professional collaboration and exciting research project of my own career at the Smithsonian. The preliminary phase in 2006 focused on 38 metal items Richard had selected for sampling, tiny bits that another staff person brought back for high-resolution imaging and elemental analysis that are part of the arsenal of analytical equipment available at the Museum Conservation Institute. The first, and so these are just pictures of the MCI, which is the building on the lower right, where I worked. The first group of results are from objects that are the earliest metal finds from the site, including a copper ring with fiber wrapping at the ends, tembaga fragments with enriched gold surfaces, and the tail part of a pendant that had been previously sampled and analyzed at MIT. Also part of the sampled group were beads found in a later tomb. Within this group within this group of analyses, you can see some compositional variation, ranging from pure copper to various compositions with the three primary elements of copper, silver, and gold. And I will just tell you that in my presentation of analytical results, the order will always be copper on the left, silver in the middle, gold on the right, which I wanted to be confusing. This process helped us shape the research project, which would, in Richard's words, address the origins and development of pre-contact gold working in Panama through a technical lens, focusing on details of fabrication and metal composition using non-destructive analytical techniques. We would include objects in museum collections, recognizing that most of them would have little to no provenience information, as well as scientifically excavated artifacts. Our team would include specialists with expertise in conservation and technical investigation, including knowledge of metalworking, goldsmithing in particular. There would be expertise with scientific instrumentation and data interpretation from staff at the Museum Conservation Institute, and of course archaeological and art historical knowledge specific to the Ainslie region. All objects in the study were documented in a FileMaker Pro database that we developed, and photographed everything, examined everything under a microscope, and recorded details of fabrication and condition in this database. Any available information from museum archives or excavation records was also added into the records. I should note that our records use the museum or excavation number, which typically represents a single object, but may also represent a multi-component object such as a bead necklace. We standardize our own assignment of secondary numbers, such as for individual beads that might be part of such complex objects. The objects were analyzed using XRF, portable XRF. Our instrument was a more specialized one. It has a chip that weighs 100 pounds, so it's still portable kind of. And it has an enclosed chamber, so the artifact doesn't have any interference from outside materials around it. It was also calibrated to gold standards so that the information could be as accurate as possible about its composition. We did all our investigations on location in museum storage areas or where objects could be safely taken off exhibit. The exception was where particular objects could be, or collections in the Washington, D.C. area, where particular objects could be brought to MCI for more targeted, non-destructive analysis as needed. Techniques included digitalized radiography, environmental SEM, where objects can be placed directly in the chamber without coding or anything, and micro XRF. One small component of our study involved destructive analysis with 5 beads that were approved for export to the United States. These underwent cross-sectional preparation for further examination and compositional analysis. So our data set was made up of a series of phases during which we tackled specific collections. In 2007, we returned to Panama to systematically analyze all of Richard's Cervantes collection, as well as all but a handful from a small handful from other sites that he had excavated, and to analyze the entire collection of the Museo Antropológico in Panama City. I'm really grateful for Dr. Tomas Mendizábal, who was then the museum director, and with Richard facilitated our access to this important collection, which has not been open to the public for many years. The 2009 phase was one that took us to the site of El Caño, but primarily to analyze all the materials that she had excavated to date, as well as a small group of artifacts that Richard had excavated from a dry field season at Pedro Gonzalez, which is out in the middle of the Gulf of Panama. The next phase focused on Smithsonian collections of Panamanian material located in the National Museum of Natural History, which is on the left in the image of the Washington Mall, and the National Museum of the American Indian, which I mentioned became a member of the Smithsonian Museum family, but prior to that had been a private collection in New York City, and many of the gold materials in NMAI are ones that were brought there because of what campus in Panama. The 2011 phase was a more in-depth focus on beads in the Smithsonian collection, along with the only aspect of our research study that involved destructive analysis. We also dealt, which included actually the excavated beads from El Caño. The 2013-14 phase, we analyzed all the collections in the Lombard Oaks collection from the Istmo-Colombian region, and then returned to Panama in 2015 to analyze more recent finds from El Caño. So at this point, our data set comprised documentation of more than 1,500 objects, of which 889 have been analyzed with XRF. For the purposes of interpretation, though, we undertook several additional steps. First, we classified every object as either Group 1, which had well-documented provenience, Group 2 with some specific designation of province, district, town, and Group 3 with no provenience. The second step related to aspects of the object's condition that would affect the reliability of the compositional data, specifically whether it had a corroded surface or a distinct enrichment layer covering a heavily corroded interior. Those in the red categories were removed from consideration in our interpretations. This chart, taken from the publication of our work to date at this point was in 2021, has the chart, and I'm showing you here. The objects on the left are all summarized by province and then sorted according to whether they were cast. Their primary fabrication was either casting or hammering. And you can see the numbers there. That's the unrefined data set. The group of columns on the right is how the numbers looked after we did the removal of more problematic materials, so that we had a good solid data set of 519 objects, of which 89 were cast and 430 were hammered. In the next set of slides, I will show you some results using our two largest data groups that are marked with red arrows on the chart, those from Cervantes and El Caño. I will mention here that individual photos of Cervantes objects were taken by the MCI team unless otherwise credited, and the ones from El Caño are from the Fundación El Caño's publicly accessible online database of finds. Cervantes is a non-elite mortuary site with just a few habitation contexts. Operation 3 with metal finds ranging from the earliest metalwork found in Panama, which I showed you earlier, to a finger ring thought to be colonial. This plan shows the Op 3 tombs, many containing multiple individuals. A total of 30 metal objects, 23 of gold, 7 of copper, were found in this excavation area, all found individually in separate contexts, with 2 exceptions. The first exception is represented by the circled tomb at the top of the plan, which is tomb 16 that had the early metal finds. The second example, circled just below it on the plan, had the most lavish artifact assemblage found at the site. In this area, 2 tombs intruding into each other comprised multiple secondary burials packed tightly together, and found with them were these 3 spiral ornaments made from hammered sheet, the only metal finds from this context. However, there was a whole lot of other stuff, which included more than 400 spondylus shell beads, perforated puma teeth pendants, agate beads, and ceramics. The other source of multiple objects, metal objects at the site, there's several more from other operations than Operation 3. This one's from Operation 7, and actually between the two other operations, there were 89 metal artifacts, 82 of which were beads, and they were all formed by hammered sheet. The vast majority of these were distributed among 2 burials, of which this is one. Here are the results, and again, the copper composition is on the left, the middle, within each group of 3 numbers, the middle is silver, the rightmost one is gold. And I've sorted them by sort of groupings, compositional groupings. Note the preference for a tumbaga-like composition for the beads in that in the leftmost column. The other ones with lower silver and lower and higher silver groups in this example. From a later burial in another operation, Operation 4, was a collection of 14 metal objects, all beads. And you'll note that the compositions all have a small amount of copper, but with similar trends based on silver content, similar to the distribution that I showed you in the previous slide. And you'll note I've flagged the ones with high silver in blue. There's only one in this group of beads. There are 2 in the previous tomb. All the rest are compositions that occur more normally. In contrast to Cervantes' modest profile, El Caño is an elite mortuary site on the western bank of the Rio Grande, which is about 2.5 kilometers upstream from the comparable site of Simposio. It has a complex concentration of tombs that you can see in the diagram. Those are about 7 different operations, each of them with multiple burials. I'll be focusing on tomb 2, which I've marked with the arrow. It had over 30 individuals in that oval depiction, but they were interred in phases over a period of time. The drawing here shows the profile of one of the burials of tomb 2, with a stratigraphic profile of the lower group of burials. So it's really, the stair-step presentation is actually all in one go, one big tomb. But the section that I'm showing you here is from the lower bunch of layers. The primary burial is situated at the base of this tomb, and it contains the remains of the so-called warrior chief, who was interred with 18 other individuals believed to be warriors. In this stratum was an assemblage of offerings, including 37 ceramics, 152 stone artifacts, and 73 gold artifacts from this stratum alone. There were 2 pairs of arm cups that were found with him, made of hammered sheet. I showed their compositions here, sorted by silver content. You can see the nice alignment of composition within each pair of arm cups. And here are the results for the gold caps made from hammered sheet which decorated 4 deer bone pendants seen in the upper left image, a selection for sperm whale teeth pendants in the second group, which is the image of 4 things right below the bone objects. And then a belt composed of, I think it was a total of 27 puma and whale teeth with gold caps. And in this case, because it was an object of belt, which is that arc at the bottom of this line on the right, because there were so many elements, we made a random selection to analyze. So we analyzed 6. So that's not a complete picture, but the other ones are complete. And you'll see a very nice alignment of compositions for the gold caps, with the 2 oddball outliers with a high percentage of gold. El Caño also had a multitude of beads. They're challenging because of their numbers, so this is again a situation where we made a selection. Despite our desire to really do everything, we really had to compromise with this one. Here is a selection of bead types with 3 compositional groups you've seen before, but not strictly aligned with bead type. So there are some shifts of position for each cluster of bead types that I should show you. The one exception of the flip-flopping between categories is the segmented beads at the bottom, which were all which shared a composition of over 10% silver. My last artifact type that I'm going to show you, and this is just a drop in the bucket as far as the materials at El Caño. It presents an interesting case, and these are the objects that we refer to as ear rods because they have composite parts. They have 2 or more standard components. The finial, which is the little cap at the top, is attached to a tube. The finial is typically cast, the tubes are typically hammered sheet, and they're joined together. The tube is open so that it slots onto a stone rod, typically stone rod. At the bottom of that rod, there's a capped tube, also made of hammered sheet. A variation is shown on the right. Oh, and I should mention the cap tube. In 2 instances, were at both ends of a stone rod, and I'll show you that picture. On the right is a variation where you have the finial attached to a long gold tube, and it may have had a perishable material on the interior. It's hollow. We routinely analyzed all these parts individually so that we could see if there was anything going on there. So this is a display of the data from the ear rod parts. And one set of ear rod, or two sets of ear rod parts. And I've shown it a little bit differently because I want you to be able to compare the comparisons, compare the compositions of the finial and the short tube, and you'll see that they all have high amounts of gold in them, the higher range that we find commonly the short capped tube that's in the lower half of the slide has a high level. Those 2 individual tubes have a high level of silver. It's possible they had some association with the ear rods, the other end of the ear rod, the finial. We don't know. But the odd thing here is that the only exception to the higher silver content are the 2 stone rods that are capped at both ends. So this information will look familiar to you. It's a work that we published in the Dunbar Notes volume, and it was something that we particularly found useful in our interpretations of the data. This one displays, actually it's not from the volume so much, but it displays the difference between the silver levels or the compositional differences between the bead study from Colombia versus Panama. And you can see the general disposition of the Colombian material is to have a higher percentage of silver. The compositions that we've seen in the Panameña material, but their particular levels of silver suggest to us that the ore was coming from a local source. that had sort of standard amounts of silver. There may have been several sources represented by our data. We don't know that yet. But the silver is a natural contaminant, if you want to call it that, but a natural ingredient in the gold ore. But copper, by contrast, is something that would have been added literally to alloy, to make an alloy. So this plot just shows how the numbers look with the several compositional groups that I showed you, with one at the lower end between 4 and 6%, one at a little higher up, 6 with like in the 8 to 10 range, and then after that it really drops off in terms of frequency of high silver objects. All these diagrams are from that publication, so that if you want to look at them in more detail, I advise you to look at the publication. It has some more information provided. We wondered whether it would be useful to look at regional, plot the data in a regional way. And one thing I want to alert you to is that the scale is not the same between these. That's something that I think would be useful to correct, because it makes it hard to figure out what's going on. But the vertical axis is the number, bar height represents the number of objects. The horizontal bar represents the silver to gold ratio that Patricia had talked about, and that we had learned early on is going to be a useful tool for looking at the compositions. I put red markers where the 8% bar is, más o menos, and we interpret the histogram showing it. So let me just mention the northern Cocle is the one on the left. Immediately below it is Cocle d'Arien. Southern Cocle is the upper one on the right. And this cluster of regions seem to have more of the higher silver material in their groups, in their inventory. Whereas the Western Chiriquí and the Eastern Chiriquí that are in the lower right don't. It pretty much stops at the 8%. In the northern Cocle one, the highest bar is at 130 objects. So you can tell that we have a lot more information from the northern Cocle, which is not surprising since Okan was the major occupant. So another thing about in the ore source comment is that the northern Cocle and the Cocle d'Arien seem to have more representation of the higher silver ore source. And here are the beads that were analyzed from Isla Pedro Gonzalez. And you'll see it's got the more median amount of silver in some of the beads, but then there's a group that has very high silver. Well, 12%, over 10% in two of them, and over 20% in another. And these are averages. We generally try to take several points of analysis for every object. The other thing that's interesting about the northern Cocle, the Cocle region in general, with access to sources that have higher silver, is that these are objects from tomb 2 burials, and you can see the frequent use of a high silver composition, ear rods and other materials. It shows up mostly in the warrior chief, who is the column on the left, where many objects from his assemblage had high silver content. But even the more modest tombs, also in other positions in that complexity of tomb 2, also used high concentration silver for the components of ear rods. So there seems to be some preferential use there. The other thing is we have some real outliers. The one from Playa Venado, which is in the Museo Antropológico Flores de Arraus, Marta, at then 26%, but an unknown Provincial stone has a very similar composition, and maybe from the same area, we don't know. Another oddity is that one object in the warrior chief's tomb is this little miniature butterfly plaque, which is a unique object for a continent. The other, I want to shift in this last little bit to focus on the goldsmiths and what their practices were. There's a person behind every object that we look at. And to see whether we can use the compositional data to understand their practices. One of the very commonly known preferences in goldsmithing is to use compositions with copper in them for cast objects. In our data set, you could see cast objects made of compositions with almost no copper to very high to bottom kind of copper levels. For hammered things, you can see the really distinct preference for low copper mixtures. It really does concentrate right there in that very low end. Joints are commonly visible in tubular sheet form objects, including beads, and also between the cast and the sheet form components of ear rods. Goldsmiths made joints by careful reheating. We have never seen any evidence of the use of solder. Another practice that we can infer from our data is that most of the individually crafted matching objects are typically made of hammered sheet, and they seem to have started from a single metal batch from which to make these objects. So you see a very tight correlation of compositions in some of these match sets. And these are actually interesting ceramic beads with a gold sheathing, so we were analyzing the gold sheathing. Another thing that we were puzzling about was just the sheer numbers of beads. They come in a wide variety of shapes, sizes, techniques, but we see the same practice of using a single metal batch for a batch of beads. We see really tight correlations within clusters of beads. But the thing that remains a mystery is how the heck they were making these. I mean, there are so many of them, and they range in size from a millimeter seed beads to 5 centimeter beads that are huge. Mostly these are sheathed beads where the resin inside is missing. But you know, you look at a couple of beads and you know that wouldn't be hard to make. But if you're talking about hundreds and hundreds and hundreds, it's a really interesting question. And so we've been pondering mass production techniques. I mean, did they make a sausage of hammered sheet, a really long sausage, and then chop it into little bits? And then the bead group at the very bottom left, the big beads, all you have is the resin sheathing, there's nothing inside. But among the little beads, there are little resin balls that are inside the beads. So did they make a bunch of little resin balls, stick them together end to end, cover the whole thing in thin sheathing, and then separate them? We don't know. So I think that's a worthy topic for the research, along with the thing that we're all desperate for, which is more information about the ore source, the compositions of ore sources in Panama. Thank you so much for your attention. I have a million people to thank.